Yeah, students, let's go over quiz number 11, taken on March 30th, 2021. Which value is not invalid for probability? Remember, probability should be between 0 and 1. This 1 is certain, and this one over here is impossible. So only numbers between 0 and 1. And if you just take these proportions or fractions and turn them into decimals, you'll see a 0.6. This one goes in there more than 1. So which one is not, right? This is a number between 0 and 1, 0 and 1. This would be 0.80. So the only one that is not between 0 and 1 is your choice, B. All right, number 2. This table represents a survey about whether boys and girls have received a speeding ticket, like driving. I know, kind of scary, you guys are driving. Part A, what is the probability of selecting a student that has a speeding ticket? Right, as a simplified fraction. So a speeding ticket would just be in this region, right? Because that's 9 boys, 1 girl, that's 10 people who have a speeding ticket, and you add the speeding ticket versus the no speeding ticket, you get the total. So 10 over 66, and then as a reduced fraction, that's 5 times 2, 33 times 2. The common multiple they have, the largest common multiple is 2, so you would get 5 out of 33 is your answer. Let's erase all this up here. Excuse me. And notice how I'm using different colors. That might be helpful for you as you complete these, right? Next question. What is the probability of selecting a girl and has not received a speeding ticket? Okay, so there are, this one has the word and, and so I want to find a girl. So I'm looking in this green rectangular box there, and not speeding ticket. Okay, so that would be a 25 over the total. Our total is 66. And I don't believe you can reduce that, so that is our answer. Part C, what is the probability? What color have we not used? Let's go to orange. What is the probability of not getting a speeding ticket given that you are a boy? So the conditions are that you are a boy, okay? So this basically means that your denominator total is 40. It's a condition, right? Only look at boys, okay? Now, I'm going to circle the word not, so let me erase everything above. Okay, so I'm looking at boys, and you can see there that the total is 40, and that's why I have this 40 or denominator down here. Okay, now not getting a speeding ticket, the word not is right there. 31 out of 40 is our answer. And then for part D, I told you guys we didn't learn about independent events, so skip that. Okay. All right. Question number 3. Out of 56 students, so that's the total. So everything that I have in this diagram will be a total or equals to be 56. 14 are taking AP Calculus. Okay, I'm going to write Calc on this side. This circle right here represents those who are taking Calculus. Okay, pay attention. That whole circle is equal to 14, okay? And then it says 16 are taking AP World. So this circle I'm going to call is World, right? So everything in the circle equals 16, okay? Now, there are 4 students who are taking both. Okay, so in my diagram here, this would be a 4, and this is 4. 4 plus what? 12 equals a 16, so you put 12 in here. I don't know, this diagram I think is helpful. And that portion again in the red is 4, so 4 plus 10, so this would be 10. So 4 plus 10 plus 4 plus 12 gives me a total of 16, 26, and 26 minus 56 gives me that there are a total of 30 people who are not taking AP Calc and AP World are together. Okay, what is the probability? So I'm going to change colors. What is the probability that a student chosen at random is only taking AP Calc? Okay, only means that they're not taking whatchamacallit? AP World. Okay, so the only person taking AP Calc is 10. Over 56. All right, so if you reduce 10 over 56, because it tells you to write as a simplified fraction, they're both even, so 2 divided by 2 is 1, so you have 5 over 28. Now, I'm going to go back and hand grade this because the Edulastic has the wrong answer. It has 3 out of 14. And why is this one wrong? Is because if they wanted, what's the probability of someone just taking AP World only? Well, that would be the 12 inside there, right? Because 14 would be both Calc and World, so 12 out of 56, and we divide that in half. You would get 6 out of 28, and then half again, you would get 3 out of 7. So this is the wrong answer that Edulastic had in there, and I have to go back and regrade it. Again, B we're skipping because it's conditional probability. C is independence, which you guys are learning in 4.4, so these are like 4.4 lessons. That's why I'm not grading those. And that's the same thing for yeah, we did that. Okay. Question number 4. Out of the 56 students, 16 are taking AP World. So let's do a color. And we already did this above, but we'll do it again. So all of this is 16. And in red, 14 are taking calculus. And so when I like to do it, I like to, that's the overlap part. And then 4 are taking both. So this portion is 4. And so if you're labeling this, this would be 4 plus something equals 16. So that would be a 12. And then over here as well, this is equal to 14. So that would have to be 10. 10 plus 4 gives you the 14. And so if you add 10 plus 4 plus 12, that'll give you 26 minus the 56. So 30 students are not taking AP World, not taking AP Calc. Okay. Number 5. For mutually exclusive events, A and B, probability of A is 5 over 10, the probability of B is equal to 1/10. What is the probability that either event A or B occurs? Okay, so mutually exclusive events mutually agree not to happen. So basically, A plus the probability of A and B happening at the same time is equal to 0. So in this formula, you're going to have the probability of A plus the probability of B, and then minus the intersection or overlap, which is the probability of A and B. Well, we just said that it's equal to 0. So that doesn't do anything, right? And then A is 5/10, B is 1/10. So if you add those together, you're going to get 6/10, which is 60 over 100, which would be 0.60. So that would be choice B. Question number 6. In a box, there are 8 red. Let's draw a box. 1, 2, 3, 4, 5, 6, 7, 8. 7 blues and 6 greens. 1 ball is picked at random. What is the probability that the ball is not blue? Probability of not blue. Okay, so remember, this is the probability of not blue is a probability of blue equals 1, right? Remember, this is back to my idea is no plus yes equals 1. And these are complementary ideas. So if I'm trying to solve for not blue, here's one of them. I can just subtract probability of blue, and then get the probability of not blue is actually equal to 1 minus. And this is the idea of complementary events, okay? So if I just figure out what's the probability of blue, well, 15, there are 21 total, and there are only 7 blue. Okay, this 1 turns into 1 over 1, and you multiply by 21 over 21. So 21 minus 7 over 21 will give you 14 over 21, which is 2/3. 0.67 is our answer. Okay, another way of getting this answer is just saying, well, the probability of not blue is getting the probability of red plus the probability of green. And green would be 6 out of 21 plus the probability of red, which is 8. And if you get those, you'll get 14 out of 21, which is the same thing as we got down here. Okay? And last one, question number, I'm sorry, not the last one. Question number 7, Dr. Stats plans to toss a fair coin 10,000 times in hope that it will lead him to a deeper understanding of the laws of probability. Which of the following statements is true? Okay, A, it is unlikely that Dr. Stats will get more than 5,000 heads. Remember, this is the idea of simulation. Simulation could happen where you might get, one time you might get 6,000 heads. You flip it another 10,000 times, and it's possible that you get only 2,000 heads. So the word unlikely, it is possible you can get that. So I don't think that is the true statement. B, whenever Dr. Stats gets a string of 15 tails in a row, it becomes more likely that the next toss will be head. Okay, remember this is the idea of no memory. Or, you know, those things like hot streaks, those are not, you know, we talked about that, doesn't happen, right? You make 10 shots in a row, it's not likely you'll miss the next one, it's just going back to the probability that you're, in this case, it would be 50% heads, 50% tails. C, the chance that on the 100th toss will be a head depends on what were the results of the first 99 results. It's the same thing, there's no memory. Or we can say in a future lesson, we'll just say these are not. These are independent events. The 99 toss and the 100 toss doesn't matter. Okay, and the last one says, it is likely that Dr. Stats will get about 50% heads. Yeah, because that is the probability getting a heads is 1/2, right? 2 outcomes versus the heads, which is 0.5 or 0.50. So D is the correct answer. All right, question number 8. Consider the spinner below, which is a sample space for the spinning the spinner at one time. Okay. This one says 1/12. Well, I'm going to underline the word sample space. These are all the outcomes. Right? You know, a big one for students, unfortunately this year, like, you know, a big event for seniors is like, oh, am I going to go to prom? It would be yes or no. That would be your outcomes, right? Or maybe there's a maybe, right? So this one, let's just count. I'm just curious. A, B, C's, D's. Okay, how many A's? 1, 2 A's. B's. 1, 2, 3 B's. D's. 1, 2, 3, 4, 5. And C's. 1, 2, 2 C's. So that would give us 5 plus 7 would give you 12. Okay. So, okay, none of those have an outcome. That would, I think this would be like a probability, but I don't think it's any of those, right? Okay, what's the next one? 1/6, 1/4, 1/6, and 5/12. Well, those actually represent the probabilities of these, right? So look over here, this would be 2 out of 12, 3 out of 12, 2 out of 12, and 5/12. So if you reduce those, you'll get 1/6, 1/4, 1/6, and 5/12. So these are the probabilities of each of those, but again, we're looking for a sample space. Okay, these are all the choices, but this is not the sample space. The sample space is just kind of like everything that can happen, and that would be choice D. Hopefully those corrections were helpful for you guys. See you later.